So now let us see on how we can be able to sketch the graphs of the exponential functions. By the way, we have two forms of the exponential functions. We have y is equal to e to the power x, and this is a typical exponential function where e is a constant and that represents some values 2.70 and somewhat about, but we actually express that one as e. And the exponential function can also be given as a to the power x. So in this case, this is actually exponential function. It is said to be the exponential function with base other than e, and where this one is said to be the exponential function with the actually base e. But all these actually functions possesses the same actually graph. Now let's say we have the function e to the power x. So now what is the graph of this function? So the nature of the graph of this function actually looks like this. The nature of the graph of this function now looks like this. This is y-axis and this is the x-axis, of which basically the graph actually goes like this. So this is the nature of the exponential function graph, and that is, and also this is also the same if we can have the function y is equal to a to the power x. So the graph actually in which the graph in which the exponential function actually possess, it is that kind of a graph. So keep that in mind. Now let's say we have this case, and where basically this is actually y-intercept, which is given as well, and that's the reference point of intercept. Now let's say we have y is equal to, let's say a to the power x and plus 2. So in this case, this constant is part of x, which is on the power, so it is the translational determinant along actual x. So it means the graph has to shift about 2 steps to the left, that is along x-axis. So which means the graph will go like this. So this is y-axis and this is the x-axis. So let's say this is where 2 is, we'll have it as a -2. So you need to come up with the actually horizontal line. Should be a vertical line going over like that. So in this case, what it means is that it means the graph will go like this. So this is the graph of our interest, and where, as you can see, the graph can be able to cut across the y-axis. Hence, in this case, the graph will have the x-intercept. Should be the y-intercept, which is at this point. So what is the x should be y-intercept for that nature? So now the y-intercept will be calculated upon having x being given as well. Hence we'll have y is equal to, should be a to the power, now will be given as 2. So this is the value of the y-intercept, and which is given as this point, e to the power 2. That is the value. And of which, upon having the value of e, you see that it will be given as, and that should be a 4 point something, but you don't need to actually express this into its little value, just have it in this way. But note that it represents a certain value, 2.70 and something like that. I don't know if, but basically, if we try to punch in a calculator, the value of A will be actually about somewhere about 2 point something, and I'm not really sure what is actually that value in case I'm wrong. But Strumo, this is actually Strumo at this point. Strumo at this point, the graph is cutting across the actually a vertical line at a point given as 1. Now in this case, we only have the actually horizontal asymptote, which is given as x-axis. So take note of that. So the graph has no actually x-intercept because the graph is no longer cutting across the x-axis. So we'll have that understand. Let's say we have y is equal to, let's say e to the power x minus, let's say 1 plus, let's say 4. So now what will be the graph of this function? So this is the translational along x, and this is the translational along y. And the nature of the graph will go like this. So in this case, the graph will be drawn in this way, where this is the actual y, where this is y and this is x in that case. So now the graph is translated along x about 1 step to the right. Let's say this is 1. So which means we'll be in need of having the vertical line and passing the point in this case. Then the graph has to shift about 4 steps up. Let's say this is 4. That means we'll have that understand. Let's say this is the 4. Now the graph now will have the actually horizontal line going off like that. And what will be the nature of the graph? Now the graph will go like this. Principle remains the same. So you can see that we have the y-intercept there. That will be calculated upon having x as which is the same as e to the power -1, which is the same as 1 over e. So this is the actually now should be like this. We also have to consider further. So which means we'll have it as now should be given as 1 over e and a plus 4. And which is really true that in this point which is really true that the actual y-intercept has to be somewhere above 4, and as you can see it here. So that's how you should have to get that an up to. And also in the same case, we have the horizontal asymptote, which is given as actually a y is equal to 4. So keep that in mind. Now how about if we have this? Let's say have y is equal to 5 to the power x minus, let's say 2, and minus, let's say 2 as well. So now principle remains the same. This is a typical exponential function, and where the graph is translated along x about 2 steps to the right, and also y about 2 steps down. So in this case, you should know that. Let's say this is 2, let's say this is -2. It means we'll have that in this way. Let me have it proper there. So in this case, the graph will go. In this case, the graph will go like this. The graph will be moved in this way. Now as you can see, we have both x-intercepts as well as the y-intercepts. So how should you have those intercepts? Let's start with the y-intercept. The y-intercept will be obtained upon having x's or have 5 to the power negative 2, should be 5 to the power negative 2 and then minus 2, which is the same as 1 over 5 to the power 2 and minus 2. So in that case it means we'll have it as 1 over 5 and minus 2. That will be given about somewhere about negative 1 point something, and which is really in line with that one. And we'll go for the x-intercept. So how should you have the x-intercept? So now the x-intercept will be obtained upon having y is equal to 0. So now which means we'll have it as 0 is equal to 5 to the power x minus 2 and minus 4. So I'll have to bring 4 to the other side. That will be given as a positive 4 is equal to 5 to the power x minus actually 2. Then in this case we're going to introduce ln both sides because we're not to be able to express 4 to have the same base power, actually to have the same base as 5, and also 5 cannot be expressed to have the base that can be the same as 4. So we'll have to solve the way we solve the exponential actually equations. So we have to introduce ln both sides. That will be given as, now we'll have it as ln 4 that is equal to ln 5 x minus 2, and that will be the same as ln 4 which is equal to x minus 2 and times, now we'll have should be ln 5. Then we'll have to expand upon distributing ln 5 all over the solve for x. That one will be the actually x-intercept, and that corresponds to this point. So keep that in mind. And how about the refraction aspects of the graph? How can the graph be refracting either along x as well as the y, and the graphs of and that should be the exponential functions. Let's say we have y is equal to, and that should be, let's say, e to the power negative, let's say x. So now what will be the graph of this function? So now in this case the graph is refracting along, so the graph is refracting along y-axis. And what would be that one be like? So you know this is y-axis and this is the x-axis. And we know that the basic shape of the graph has to go like this. This is the basic shape of the graph in that case. But now since it is refracting along y-axis, and the graph has to look like this. Then the graph has to look like this. Let me have it proper here. Then the graph has to look like this. So that's how the graph of this function will have to look like. Whereas Trumo, this is actually a point 1. And we have the horizontal asymptote, which is given as this, like that. And this is y-intercept given as 1. And should we talk about the domain as well as the range? The domain is corresponding to all values, that is negative infinity to positive infinity, if we think of talking about the domain. And the range corresponds to 0 to positive infinity, of which the 0 will not be part of the interval. That is. And let's say we have, for this case, let's say have y is equal to, let me use another ink here. let's say we have it as y is equal to, let's say, negative, should be e to the power negative x, and a plus 5 minus 2. So what would be the graph of this function? So we are having the translational determinants in both axes, and also the graph happens to reflect along y-axis. And what would be that one be like? And let's appreciate how the graph will be actually sketched. The graph is translated along x-axis and 5 steps towards the left. Let's say this is, where 5 is. Let's say should be given as negative 5. So we'll have to come up with the vertical line that will go like that. And the graph is translating about, should be 2 steps down. Let's say this is 2. Then now we'll have the line that will go like that. You should know that. And on the same case, the graph is refracting along y-axis. So which means the graph will go like this. The graph will go like this. So as you can see, we'll have both x-intercept as well as the y-intercept that way. So try to have the values of those intercepts. On the same case, this is the horizontal asymptote, as you can see. In the domain, the values ranges from 2 to post infinity. In the range the values ranges from 2 to post infinity, where 2 is not part of the interval. The domain are all real values. So try to have that an out in that case. Let's say if we have this case, let's say have y is equal to, let's say, negative 5 to the power negative x. Let me have this negative 5, let's say, to the power negative x, and a negative 2, and a plus 10. You also have it in the same way, like the way we actually discussed the previous one. What if we have, let's say, y is equal to negative, let's say, a to the power x? So what is the graph of this function be like? So now this is the reflection along x-axis, and this would be the nature of the graph. You should know. You know, this is y-axis and this is the x-axis, and the graph will go like this. So the graph now will go like this, and this is negative 1. So that's how the graph has to reflect along, should be x-axis, and therefore that case, let's say we have it as y is equal to, let's say, negative 2 to the power x and a plus 5. Let's say we have 3x. So whichever the coefficient of x doesn't matter, but what matters is the coefficient x actually a negative or positive. That's what matters. Let's say plus 2. So in this case, this is the typical exponential function, where the graph is translated along x as well as the y. So what would be the nature of the graph? And also the graph is reflecting along, should be x-axis, in that way. This is y and this is the x. Now what was this? Let's say we should have it as 2. So the graph is moving 2 steps up. Let's say this is 2. Then I'll come up with the horizontal line, like that. And the graph is moving 5 steps down. Let's say this is 5. It means there should be 1. 5 steps to the right. Let's say this is 5. So which means I'll have this. So that's what will happen. On the same case, the graph is reflecting along x-axis. So which means the graph will go like this. So we'll have the x-intercept, and we can also see that we'll have the y-intercept here. So that's how you should have to understand about the graphs of the exponential functions. So now try to practice these at your own times. Let's say you have y is equal to 5 to the power negative x plus 2 minus 2. Y is equal to negative e to the power negative x minus x, and let's say plus 5. And you have y is equal to negative e to the power x, 5x minus 4, and plus 10. And I specify the domain, range, intercepts, as well as the asymptotes where necessary. So that's how the graphs of the exponential functions can be actually plotted, can be sketched. Thank you.